Today we are going to work on permutations and combinations and geometric probability. So first off, we are going to review what permutations and combinations are. So remember, permutations are arrangements where order matters. And when we deal with a permutation, we write down the number of blanks we're trying to fill and then fill in the appropriate numbers and multiply across to find what it equals to. Combination is an arrangement where our order doesn't matter. And we're going to use our calculator and go find our total number of objects is in and how many objects or people we're choosing. And that's R. And then we plug it in, NCR, or in, and R. Okay, so suppose that you have a bag that contains 3 distinct colored marbles, red, green, and purple. And you wish to draw 2 of those marbles without replacement. So on the first one, order matters, meaning we have permutation. We're choosing 2 objects. And the first one would have a 3, and then a 2. And 3 times 2 is 6. And then we're doing order doesn't matter, meaning that we have a combination. We have 3 things total to choose from, and we're choosing 2 of them. So we have NCR 3, 2. So that's going to be menu probability combination 3, 2, and get us 3 possible outcomes. So if we used a combination, we'd have 3 possible outcomes. If we had a permutation where order mattered, we'd have 6 possible outcomes. So next up, now suppose you have a bag of 2 red marbles, 3 green marbles, and 4 purple marbles. And we want to draw out all 9 marbles and place them in order they're drawn. And we want to know how many different arrangements are possible. So this is a permutation without replacement. And it's like the Mississippi problem. So we need our total number of marbles. So 2 plus 3 is 5, plus 4 is 9. We have 9 total marbles. So we're told we had 9 marbles. We have 2 that are reds, 3 that are greens, and 4 that are purples. So we'd have 9 factorial over 2 factorial, 3 factorial, 4 factorial. Again, I highly recommend pressing Control Divide first, so you get your fraction and don't have to worry about parentheses. 9 factorial over 2 factorial, 3 factorial, 4 factorial, and we get 1,260 possible arrangements. Next up, student council members have selected 12 students to choose from to fill the positions of president, vice president, secretary, and treasurer. Each student can only fill 1 position. How many different outcomes are possible? So this means we have a permutation, so we need blanks because order matters. And we know order matters because we have 4 different spots: president, vice president, secretary, and treasurer. Then we have 12 people to choose from. So we could choose any one of 12 people for the first position, then 11 for the next, and for the next, and 9 for the next. So 12 times 11 times 10 times 9, and that gets us 11,880 possible outcomes. The next one, student council members have selected 12 students to choose from to fill the positions of a 4-person committee. Each student can only fill one position. How many different outcomes are possible? So this one, we have a combination because order doesn't matter, because it doesn't matter who is chosen first or second or third or fourth. It just matters that they're all in a group. Order doesn't matter. So we've got a combination, so we need our total, which is 12, and we're choosing 4. I've got NCR 12, 4 in combination. So menu probability combination 12, 4. So we have 495 possible outcomes. Our next one. Brett takes a 5-question multiple choice geometry quiz. Each question has 3 possible answer choices, A, B, or C. So we have a permutation because order matters. So we're going to draw our blanks. And how many blanks are we going to have? 5 blanks, because it's a 5-question quiz. And then how many options do we have for the first question? 3. How many options do we have for the second question? 3. How many options do we have for the third question? 3. How many options do we have for the fourth question? Also 3. And the fifth question? Still 3, because all of them have A, B, or C as an answer choice. So we have got 3 times 3 times 3 times 3, also known as 3 to the 5th power. So 3 5th power is 243 possible outcomes. And then we want to know what the probability of making a perfect score, meaning 100. So there's only one way to answer each of these questions and make a 100. So our probability for a perfect score is 1 out of 243. Now the next one, what is the probability of making a 0? Now 2 ways for each of these problems to get that problem wrong. So that's 2 to the 5th power. And to the 5th power is 32. So there's 32 ways to make a 0. So that means our probability would be a 32 out of 243. And we need to go check and make sure that that is reduced. And it is. So 32 out of 243 is your probability for making a 0. Next up, the sample space is the probability of back up. Sample space is the set of all possible outcomes in an experiment. So when you find the probability, you take the number of outcomes in your event over the number of outcomes in your sample space. For our first example here, a point is chosen randomly on segment A, B, on the probability of each event. So we need to figure out first what our total for AD is. We have 4, and 3, and 5. That's a total of 12. That is our sample space. And the first is that the point is on segment AC. So AC is 4 and 3 together. So 4 plus 3 is 7. So we have 7 over 12. Now, sometimes you leave it as a fraction, and that is reduced. You need to make sure you're reducing your fraction. Sometimes you'll see it as a decimal. So 7 twelfths as a decimal is 0.5833, and we'll just round to hundredths place. We've got 0.58, and sometimes you'll see it as a percent, do 58%. Our next one, the point is not on segment A, B. So we don't want anything that's on AB, meaning we want everything else. We want B to D. So 3 plus 5 is 8. So we'd have 8 twelfths, which can reduce. It should be reduced to 2/3. And that as a decimal is 0.67. And as a percent is 67%. Because remember, you just move your decimal 2 places to the right. And then our next example, we want to use a spinner to find the probability of each event. So first off, remember that there are 360 degrees in a circle, and there are in fact 360 degrees here. Don't believe me, you can add all these together, and it equals 360 degrees. So our first one, we want to find the probability of the pointer landing on red. So red is 80%, or 80 degrees out of 360. So we need to reduce that fraction. So 80 divided by 360 is 2/9. And we need that as a decimal as well. And we get 0.22 or 22%. The next one, the pointer landing on blue or purple or blue. So on this one, purple is 75 and blue is 60. We add those together and that gets us 135. So we'd have 135 out of 360. We need to check and see that is reduced as a fraction. 135 divided by 360 gets us 3/8. And as a decimal, that's 3.038. And 38%. And the last one, the pointer not landing on yellow. So yellow is 100. So you can take 360 minus 100, and that gets us 260. So 260 divided by 360. We need to reduce that. 260 divided by 360. And that gets us 13/18 for a fraction and 0.72 for a decimal and 72%. Percent. Please make sure that you are reducing your fractions